is the AFSIS soil project, which was funded, I think, by Melinda and Bill Gates organization, which is a project that I think ran for almost 10 years. They produced very nice maps about soil chemical properties, soil physical properties, and also there is also another data set like tropical rainfall, which came to an end, I think, in the year 2012. There's also soil moisture and also the prediction. So if you look at this data set in total, it's around 500 gigabytes. But at the end of the day, if you are to give this to a farmer, it will not make any sense to them. And most in Kenya, you find that extension officers are usually not very vast in aggregating this information. So for the processing, I used OGC's web mapping services, which are quite efficient. And the data set, of course, they're hosted in the cloud. For the dissemination, I came up with this app that is called the Kenya Fertilizer Recommendation App, which is hosted on Google Play Store. So next slide, please. So in the next few slides, I'll show you, you can skip this. This is the technical implementation, which of course, if you want, I can share the slide. So this is the application that I came up with. It is hosted live on Google Play Store. So if you open the map, it's very simple. It shows the map of Kenya. In the front screen, it shows the agroecological zone. Then it also provides a capability for someone to search. Then in the menu bar, it provides a way in which somebody can do a quick query if maybe you don't know how to use maps. But if you know how to use maps, you can navigate, you can pan, you can zoom, you can also search. Then also you can have a view of some of the soil chemical properties that were processed by the AFSIS soil project. Next slide, please. So for example, let's assume that you had searched for Kitale. Maybe Kitale is your area of residence. So if you search for Kitale, the app will basically drill down based on the location that you have provided, and it will extract the agroecological information, rainfall information, soil, chemical, and physical property. So if you see in the next, in the second screen there is these soil chemical properties like soil organic carbon, nitrogen. So these layers are provided as layers hosted in the cloud. And if you search, it will go and drill down using the OGC web standard. Then, of course, it will be shown first the crops that are suitable for the first season, second season. Go to the next slide, please. So, of course, if you scroll down, you will see which crop are suitable for the second season, perennial, and also fertilizer recommendation for the same area. Next slide, please. So which were expected proposal application of the research is on-site crop variety selection, physical chemical properties, fertilizer recommendation, and used to predict, for example, historical rainfall and future rainfall. So the reason why I came up with this is that if you look at the amount of data that is provided and shared, of course, these are lists of some of the data providers that we have. If you look at the amount of data that is available, of course, they cannot fit inside a phone, but using OGC web services and geospatial technology, we are able to compress this and deliver it to the people who need to make decision in a much easier way, like a farmer, like extension officers. So the next slide. So these are, of course, some of the people who provided data, and I thank you for participating, and I'll welcome questions at the end of the session. Thank you.
Thank you, Eric. Bako, if you are ready, please, in the interest of time.
Yes, Emmanuel, I'm ready. Have I to share my screen or you?
I'll do that in a second, please.
Okay, thank you.
Here we go.
Okay, thank you. Thank you, Emmanuel. Good morning, good afternoon, good evening, depending on where you are. So I'm Bako Maman. I'm working at Agreement Regional Center. We are part of the Digital Africa initiative. So we put in place one product development team. Is on behalf of this team that I want to present the Cropland extent for West Africa. Next. So this is the outline. Okay, thank you so much. So in terms of introduction, we can say that higher level crop-based product that can be support for that can support food security, require accurate cropland extent maps indicating where cropland occurs. The current cropland extent maps are either inaccurate, they have perhaps sometimes too coarse spatial resolutions, or are not updated regularly. This is a kind of a gap that we identify. And to fill it, we want to come with a product which will be accurate, with a high resolution and regularly updated. Next. So the objective of the exercise that we are trying to do is to co-develop a continental cropland extent map using Sentinel-2 satellite imagery with 10-meter resolutions. We want to start with 2019. We want to reproduce the map every calendar year, if possible. And for that, to cover all the African continent, we separate crop mask per simplified agroecological zone, and we come with 7 that we have in the map. And the aim is to have an overall accuracy more than 80%. Next. So in terms of methodology, we started to collect the reference data, and for that we have 10 analysts from the 5 institutions involved in this initiative. They spend more than 1,100 hours with on Collect F to collect the samples that we needed. And for that, we have more than 12,000 samples that we collected. So you have at your left what we use in terms of to validate the data. We use 1,800 validation samples, and for the to train the model, we use more than 10,000 to train it. And the overall accuracy, after collecting all those data, we externally validated it, and the accuracy is more than 96.5% of accuracy. So this is the methodology, the algorithm in terms of methodology. So we split the Sentinel-2 time series into 2 6-month seasons, meaning January to June and July to December. We generate composite statistic, band indices, and ancillary datasets. With random forest classification, we produce the pixel-based mask, and with the image segmentation and majority vote, we produce the object-based mask too. Okay, next. So this is the first result that we receive. The first result is related to the eastern part of Africa. So you have, we cover 5 countries, namely Kenya, Tanzania, Ethiopia, Burundi, Rwanda. So you have the map at your left, and you have some illustration for the zooms that we did in Ethiopia and of Addis Ababa. So in terms of for the validation of the products, we use 300 samples, 100 for the crop and 200 for the non-crop. and the overall accuracy of the product is 90.3%. And you have the link here. The link is here. You can have access to it. I can let me. So I share the link. You can have access to the link to see what we receive. So this is for the eastern part of the continent. Next. Emmanuel. Okay, so you are going too fast. Yeah, okay, thank you, Emmanuel. So this is so to cover all the African continent. I said that I show you the part of the eastern part of Africa. So now we're working on the northern part of Africa. We have 94% of accuracy, and the western and southern Africa, we have 85% of overall accuracy. So we are working on this, and we think that after covering all those parts, we can get a product can cover the whole African continent. Next. So as I said, it's a kind of we are co-developing this approach, and during the development, we come with some topics. Sometimes this is an example of how we can use NDVI anomalies to identify crop stress, or where it's possible we want to see how we can identify irrigated versus non-irrigated cropping. Next. So in terms of the implementing partners that are involved in this initiative, you have RCMRD, you have OSS based in Tunisia, Tunisia. We have Afrigis based in Nigeria. You have Agreement in Niger, and Nadamo in Ghana. So all the products as they are available to everyone free of charge online through the Digital Africa platform. You have a Maps Sandbox, or via open web services for GIS desktop analysis. I think this is the end of the presentation. Thank you so much.
Thank you very much, Bako. Ladies and gentlemen, I know our time is run out, but we have one last presentation that I think I'd like us to have, and that is a presentation by Asmat Ali. Asmat, if you're ready and you can share your screen now and make your presentation. Thank you.
Okay, thank you very much. And let me start.
Can you share your screen, please?
Moment.
Are you having any challenges sharing your screen?
Yes. But the presentation is still in G Drive. I don't know what kind of issue is there.
Are you able to now?
Still not.
In the meantime, as Asmat gets ready, could we please put our questions through in the chat box so that we can put them out to the presenters who just made their presentation.
Yeah.
Are you ready now? Okay, to Kazi Mohammed Yasir, I have a question for you as we wait for the other presenter to put up their presentation. You made a very interesting presentation where you actually make some very interesting conclusions. You conclude that the cotton yield on the Indus River Valley River Basin has been significantly impacted by climate change. And therefore you recommend the use of heat-resistant varieties and the adoption of appropriate cotton cultivation to mitigate climate change in the future. I'm just wondering, because you didn't make this distinction in your presentation, are there any significant differences between large-scale and smallholder farms within the study area? Are they impacted differently by the reported changes? And if so, what could be the reason? If you could answer that as Smart prepares to.
Can you hear me?
Oh, you ready?
Yeah.
Okay.
So your question, I got your question. So the main thing, it's all depend upon the study area. So you have to look at the different climatic indicators that which one is affecting that. As far as our study area is concerned, so here is the temperature is the main issue, and the second one is the precipitation. So we studied this study area, so we got this result that these two are the main significant like indicators which are impacting our cotton yield production, but it could be different in the different study area.
Thank you, Kazi. I can see Asmat is ready now. Can we have your presentation, please? Please go ahead and share your screen.
Yes, please. Is it okay now?
Yes, it is. Please go ahead.
Okay, thank you very much and welcome to our presentation. My name is Asmat Ali and my co-author is Mr. Mohammad Manir. We are practitioners as well as we are also doing PhD. Practitioner mean we are working in Southern Pakistan, so we do know very well how things go about data and policies. The focus of our presentation is what kind of role we can expect from special data infrastructure being developed in regions for achieving food security. This is the outline which you have seen almost, it's the same. First of all, I will do a little bit talk about introduction, then statement of the problem, implementation plan of activities, outputs, conclusion, and after conclusion, expected web services, stakeholders, and the end users. Before jumping to introduction, I would say a little bit about the background. The Economic Cooperation Organization is an Asian political and economic intergovernmental organization which was founded in 1985 in Tehran by leaders of Iran, Pakistan, and Turkey. Basically, the platform is meant to discuss ways to improve development and promote trade and investment opportunities. There are 10 countries in this regional I would say organization, and this includes Turkey, Iran, Pakistan, Uzbekistan, and some other federation, Russian Federation, which was previously part of it. Now coming to introduction, the ECU member states are facing the challenge of food security. It's not a big surprise because many regions in the world are facing it. So when we are facing the same challenges, then we should also try to make collective efforts to devise some common solutions. And to address the challenge of food security, special data has the power to recognize the problems and propose the solution scientifically instead of talking just literary talks. Therefore, regional efforts can be put up to develop ECU SDI, that's a kind of regional SDI, so that we can know that what kind of food security issues are and where these are most vast issues and how we can investigate. Statement of the problem, certainly food security is a global issue and it's also present in ECU member states. Spatial data sets can help us to solve these issues, and also let me add, to identify these issues. And these issues can be addressed, as previously Kadi said and Bruce said, also many presenters said, that we need special data, whether we are talking about climate change, food security, and also some health issues. Why we are talking about ECO member states SDI? Because their borders are common. If we are sharing rivers among these 10 member states, then why we are not sharing their data? It would help us to propose and to find out good or sustainable solutions. Now, what are the land activities? How we should start? First of all, we must have a coordination committee of the member states so that relevant rules and policies can be put together, and also can be drafted new policies to share information if these policies are not there. Next
Could you
is
wind up in 2 minutes, Asmat? In 2 minutes,
okay.
please.
Okay. Collection, and then the next step is collection of agriculture or food related data and to link it to special data attributes. And the next one is we have to design, develop, and deploy a regional STI portal. As a presenter earlier said, that it would be much easier to pull down data from the portal. And certainly portal data will help to share agriculture information. The expected outcome would be a well-functioning ECOSDI, I mean geoportal here for the sake of time. And it would give access to farmers, consumers, and also other stakeholders. Coming to conclusion, geoinformation is a key component of agriculture and food security. No doubt about it. The regional SDI in ECO will enable access sharing of geoinformation among ECO member states for strengthening food security, also for economic development, and the quite recent challenges of COVID-19. All member states will benefit through sharing of agricultural information. Just a couple of web services that can be harvested through this SBI, that is WMS, WFS, web processing services, web coverages, and file services. Collaborator, certainly research institutions, national mapping organizations, food authorities, farmer and traders organizations, and consumers. Thank you very much for listening with patience.
Thank you very much, Asmat. Ladies and gentlemen, we've run out of time, but I have one quick question for Eric and another one quick question for Bako. For Eric, my question is that you have a great app here dispensing, very useful information in terms of crop suitability, agroecological zones, climate, soil, and all the rest. But how about culture? Won't this still influence the decisions on what actually gets planted on the ground? Won't people's culture still dictate what they plant at the end of the day? That is for Eric. As you prepare to answer that, I have one quick question for Bako. And Bako too, I note that you've done some quite commendable job, attempting to reproduce the map every calendar year and at a spatial resolution of about 10 meters. But the question is, to what extent do government policymakers make use of this data in planning for food security across the continent? Do you have any control on the level and pace of uptake of the beautiful research results that you're putting out there? If you can answer those quickly enough.
Yes, I think I'll start, Manuel, if it's okay.
Please go ahead.
Yes,
Please go ahead.
Yes, Manuel, thanks for your question. So, in terms of decision making, what I know is that decision making usually involves a lot of factors, and of course, farmers usually make a lot of decisions in terms of like which crop to plant. Of course, culture can play a very important role under social economic aspects. So at the end of the day, the app basically provides the farmer with the different options. It's not only a single option. So if you look at, for example, which type of crop to plant. So when the farm management handbook was being created, test sites were created in various counties all over Kenya. And in each of these counties, they looked at the traditional crop being grown, the cash crop alternative, and also exotic like perennial crops. So basically, a farmer will have a variety of choices. So at the end of the day, it depends on what they'll prefer. If they want to make money, they can decide to use to plant cash crop, of course, with other inputs like fertilizer. But if they decide to go with the traditional option of following their culture and probably planting local crops, it's still at the end of the day their decision. The important part of the app is to provide them with a way in which they can decide what to do. Yes.
Thank you very much. Thank you, Eric. Barco, please, if you...
Yeah, Emmanuel, thank you so much for this question, but it's not so easy to give the answer so easily, but I will try. As you know, Emmanuel, in this working group, having this service, as we said, is a gap that we want to fill. Filling the gap means that for the food security, we know that we need some products or some service to make our decision makers to make the good decisions. If I take the case of crop yield, if we have a result, you don't know exactly on what types or where the result, is it related to crop or not? You don't know exactly. That's why we say that we will try. It's a challenge. We will try, and I think at the end of the day, we will come with a service so accurate that will be in line with the expectation of our decision makers. Thank you.
Thank you very much. Ladies and gentlemen, I think we've run out of time. It may not be possible to ask all the questions we have. Nevertheless, I think we've seen how Earth observation technologies are increasingly being harnessed to better plan for crop production across the world. Now, this is crucial not only in ensuring food security, but also in boosting household incomes from agriculture. Indeed, there are great potentials in this field, and we can only hope that our stakeholders involved can faithfully leverage on the strengths afforded by these great technologies to help bolster crop production, and especially now that we live in the shadow of climate change and its ever-intensifying impacts on our lives and livelihoods. There was a question for Rose, but I think she'll be able to handle that in a minute as she brings us to a close to this session. Rose, please, if you're ready, the floor is yours.
Okay, thank you very much. Thank you to all the presenters. Quite a commendable job done there. We appreciate each of you wishing to present at RCMRD International Conference. We look forward to more collaboration. We look forward to looking into some of the tools, especially the applications. And we are appreciative of all the time that the participants have taken to stay in the session. And all the best. Thank you very much. Good evening.
Thank you, everyone, and bye-bye.
Bye-bye.
Okay, bye-bye.